All right, welcome back. We're on chapter 9.1. This is our last chapter of the year, and we're going to be talking once again about similar triangles. Okay, what's special about these similar triangles? These are similar right triangles. They're a specific kind of triangle. Our goal for this is to be able to solve problems, including similar right triangles. And what a similar right triangle is a triangle. Here we have our main triangle. If we look here, we have the hypotenuse. And we have an altitude coming off the hypotenuse to the vertex of the other side. By this altitude coming off the hypotenuse to the vertex of the opposite side, what we actually do is create three similar triangles. So, look at this. How many triangles do you see? Well, we just sort of gave that away for you. So, if we're looking at this, let's go ahead and look at the big one first. The big one is one triangle. Now, because of the altitude here, here's the second right triangle being in this corner here. Here is a third right triangle in this corner here. Now, if you notice what I'm doing, just to help you out here for the first time seeing it, I'm going to go ahead and color in the right triangles. So we know the blue one's right triangle stands for the big. The yellow one right here stands for the medium-sized one, and the smaller one stands for the orange one. So we know how many triangles we see here. We just talked about. We see three triangles. Now what we're going to do to go ahead and help us out a little bit here is we're going to go ahead and fill in the degrees for all the triangles. If you look here, we know this is the big triangle, the blue triangle. We have a right angle right here. This side, or excuse me, this angle here is 24. Well, if we take this angle and subtract it from 180, we're going to be left with angle M up here. So we go ahead and take 90 and 24, subtract that from 180, and this angle here, it's a little tough to see, is 66 degrees. Now, if we take the smaller one, the yellow one, here's the right angle, so here's the 90 degrees. This is 24, so the same as the big triangle. 90, 24, the other angle here, which is part of the bigger triangle's right angle, this part of this angle is going to also be 66 degrees. Now, hopefully you're thinking about this. Well, if this one is 66, 24, 90, this one here is similar, it's 66, 24, 90. What do we know about this one? Well, we know it's 66, we know it's 90, so the missing angle here is 24 degrees. Now, when we're going to go ahead and look at these, another way to look at them is to put them all in the same direction. So I'm going to go ahead and do that now. So, first I'm going to draw the big triangle. We're going to have the right angle in this corner, so I'm sort of flip-flopping it, but I'm making sure I name it with the letter O. Now as I go out here to the tip, here's where the N is, and if I go all the way up, this is M. Now I know the measure where N is 24 degrees, and I know the measure where M is right here is 66 degrees. Okay, this is our large one. So we'll put an L there. Now I'm going to make a slightly smaller one. Now I'm looking at the yellow. So I'm starting with the right angle. The right angle is at P. If I go out to the thin portion out here, we have N. And if I go up the altitude to the other side, we have O. So I know N is 24 degrees, so O must be 66 right here. This is our medium triangle. Last but not least, we're going to draw in the small triangle, the orange triangle here. At its right angle, we see P. Okay, the long portion here goes to the O, and our hypotenuse is across here, O to M. Now look at the measure of M, that's 66, and this is 24. So what we notice is all three triangles have the same measure. And just to help you out with that, I'm going to go ahead and color this one yellow, and the smaller one orange. So, which of these triangles are similar? Write a similarity statement. This is nothing we have not done in the past. Okay, we've written similarity statements before. Okay, we have three triangles here, so we can say L is similar to M, L is similar to, this is our small one. We can say this one's similar to this one's similar to that one, and S is similar to both. So, we're going to start out here with triangle. I'm going to start with the 24, M-O-P. Excuse me, NPO. That's going to be similar to triangle. So we have NPO. We're actually starting with the middle one here. And we're going to compare that one with the smaller one. We're going to go in the same direction from the 24 to the right angle, okay, to the 66. So OPM. Next one, we'll do triangle MPO. That's going to be similar. So here we have MPO 66 to 90 to 40, or excuse me, 24. That's going to be similar to triangle MON 66, right angle, 24. And our last one here is going to be triangle NPO is similar to triangle NOM. So now we've named all three similar triangles. Remember, for triangles to be similar, if similar triangles, one, all angles are congruent, and two, corresponding sides are proportional. So, knowing this, we can go ahead and create our statements of proportionality here. You guys have seen these before from the past. And here for our first two triangles, we'll do these two up here. We have NP over OP. We have PO over PM. And we have NO over OM. Now I'm going to do another one here. We have, now we're going to be dealing with this one here. It deals with MP, so we're dealing with the orange one, over MO, which deals with the large one. Then we have PO corresponds with ON, and last but not least, MO corresponds with MM. Getting to our final one, now we look at triangle that has NP in it, so that's the yellow one here. So we have NP over NO. Next we have PO over OM and NO over NM. Now we're going to go ahead and stop this now.